I'm just going to continue with just working more problems. You don't have to watch this if you're comfortable with the problems. Number 10, simplify giving your answers in simplest rational form. So we'll take this one here. We have 5 squared, which is 25. We add it to 5 to the first, which is 5, and we add that to 5 to the negative 1, which is 1 over 5. What does that equal to? What's the simplest form? We could put that in. We can put 25 plus 5 is 30, plus 1/5 is equals 0.2, so the answer is 30.2. Write as powers of 2, 3, and or 5. So we'll do number 9 here. Let's see, 9 to the k. We can write that as a power of 3, right? Because 9 to the k is 3 times 3 to the k. 10 is equal to 2 times 5. So we'll put that in the bottom there. That's pretty much done, right? We could put, if we want to put everything with powers, we could put 3 to the k times 3 to the k, which would be 3 to the 2k, okay, divided by 2 to the first times 5 to the first, something like that. Read about Nicomachus's pattern on page 84 and find the series of odd numbers for 12 to the third, 7 to the third. If you remember, that was just saying that, hey, if you take 3 consecutive odd integers, that makes a cube root or something like that. So basically, 1 is a cube, right? 3 plus 5 is 8. That's a cube of 3 or 2. 7 plus 9 plus 11 is equal to 27, which is a cube of 3. So to get the cube of 5, you actually do 21 plus 23 plus 25 plus 27 plus 29. That's 125. Okay, so you just keep going like that, always adding one more odd than the previous row. So the next one would be 31 plus 33 plus 35, 37, 39, and this would continue on, and this of course would be 6 cubed. And to get 7 cubed, you have to continue one more row. To get 12 cubed, you need to continue a lot of rows. Okay? All right. Chapter 3, Section 7. Now, let's see. We're only going to do A, C, E, G, I here. Write as a single power of 2. Let's see. So we'll do this one here. 1 over the cube root of 16. Well, 16 is equal to 2 times 2 times 2 times 2, right? Which is 2 to the 4th. And it's the cube root of that. So it's 2 to the 4th cube root, okay? And that's all over 1, right? So that is actually equal to 2, you can like multiply these two together, right? 2 to the 4 thirds, and it would be negative 2 to the 4 thirds because it's the inverse, right? Okay. Let's see. This one also we're going to do A, C, E. Right as a single power of 3. Let's see, that's 1 over 3 times square root of 3. Square root of 3 is 3 to the 1/2, right? 3 to the 1/2. Oops, that's terrible writing. 1 over 3 squared times 3 to the 1/2. If you have 3 squared times 2 to the 1/2, you can add those together. Add the exponents together, you get 1 over 3 to the 2.5. Since it's an inverse, you could put 1 over 3 to the, oops, sorry. You could, invert that. You could have 3 to the negative 2.5. Okay? This example here is just showing how to use your calculator. Basically, you just use the caret. Let's do a few of these. A, C, E, G, I. Should we do I here? Write the following in the form a to the x, where a is a prime number and x is rational. Okay, so 32 is basically 2 times 2 times 2 times 2, 5 times. So the only prime number in there is 2. So we need to put 32 as a power of 2, which would be 2 to the 5th, I believe. And then that's the cube root of that, right? This is a 2. It's kind of messy. And then that's all inverted. So remember that if you have 2 to the 5th cube root, you could write 2 to the 5th over 3rd, right? And then over 1, you could put negative 5/3 there to make it in this form here, okay? Use your calculator to find, and they give us a whole bunch of weird ones here. We're going to do A, C, E, G. It says 1 over the cube root of 7. So let's use our calculator to figure that out. So 1 divided by 7 cube root, which would be 1/3. Is that what they said? 1 over the cube root of 7. Okay. So it's 0.523. 0.523. Okay. Let's do these. We'll do the last one here, which is 27. This will be the last problem. 27 to the negative, it looks like 4/3. 27 to the negative 4/3. And what am I doing here? I'm going to use without using the calculator, write it in simplest rational form. Well, of course, they were very careful to give us a certain number, that number being 27 to the 1/3 to the negative 4th. So we took the 1/3 part of it, we put it inside because we know that 27 has a cube root. The cube root of 27 is 3 because 3 times 3 times 3 is 27, right? So we can make the inside of this turn into 3, and then the exponent is negative 4th. And so that's the answer, right? Okay, right in simplest rational form. I'm not sure if that's simplest rational form. Maybe it's 1 over 3 to the 4th would be simplest rational form. Or maybe multiplying it out. 3 to the 4th. That would, 3 to the 4th would be 81, right? 1 over 81. Maybe this is simplest rational form. Okay? And I think that's it, because the next one is already section D, right? Yeah, we're not doing section D yet. Okay.